Thank you very much. I think you all must have heard about our product and the fact that it's such a controversial issue worldwide, as everybody is trying to claim the answer to solve the big problem with regards to emissions. And everybody is trying to get onto the bandwagon when it comes to fuels. Now let me just pacify you in saying that we are not unique when it comes to just another product, because the market has been flooded and inundated with products for many, many years in trying to solve all the issues that comes along with fuels and so on. And be it fuel conditioners and lubrication additives, and there's a plethora of different products. And needless to say, there is a big stigma attached to the fact that everybody is trying to use additives. And why would they use additives if fuels are manufactured by the big majors? And it is a fait accompli that the majors do not make mistakes. And it's a wonderful thing, actually, a wonderful image to have. However, I must admit and must say to you, and I say it in all modesty, but I say it as a fact, that the big majors do things right. But unfortunately, the general public have been mesmerized in ad nauseum in believing whatever they get from the top quality companies is the answer. And unfortunately, it's not the truth. When it comes to combustion, it's quite a very sophisticated method or action that's taking place. And I'm going to try and simplify it to the best of my abilities. And needless to say, there would be a lot of inconsistencies that would be put forward by the purists of maybe those in the crowd or maybe the listeners, due to the simplification of what I'm trying to convey to you with regards to combustion. They are of the opinion that combustion normally has no problem to it because the latest technology in engine design just makes it so impossible for having incomplete combustion. You need to understand it's not because of the development and the research that has been done on the technical side, on the engines, that creates the problems. But it's more likely due to the inefficiency of fuel to properly combust. Now the question always is of such that but combustion takes place at a pace of 98%. And that's totally untrue. Scientifically, it can be proven that combustion only takes place at about between 65 to 70%. But today we're going to give them the benefit of the doubt in saying that they have reached a figure of, say, 80% of complete combustion. The question immediately is of such, and let me start in saying, if combustion is so sufficient and efficient, then my contention is when fuel burns, it should only form carbon dioxide and water. And therefore, the unassailable question is then, why does it form, in addition to that, carbon monoxide, hydrocarbons, aldehydes with obnoxious smells, so many unclean fuel that gets clogged onto the fuel lines, as well as the unclean appearance of motor oils. That obviously tells you the story that we do have a problem, and that is incomplete combustion. And if they address that, if they can only get combustion to be at the level of carbon dioxide and water, then we say that's fine, we do not have to do anything about it. Now you have two extremes. You have the engine manufacturers that obviously is doing a great job, but you do have the other part of the problem, and that is the refineries. The refinery process when it comes to fuels and the quality of fuels, be it South Africa, the United States of America or worldwide, is not of the highest qualities. And we are in the process, or the process allows it to even decline over the years to come. So needless to say that we will have to do something to improve the combustion process of all fuels. Now if we look at just, let's emphasize for this moment just on diesel fuels. Although we know there is a vast difference between the combustion process of petrol and diesel. But just for this session, let's focus on diesel. As diesel, I believe, is of more importance to you, as the market that you are penetrating is 80%, equates rather to diesel fuels. What are the important part of combustion also, or the important component that plays a critical role in combustion is your injectors. Now, one have the tendency to just overlook what the mechanism of the injectors is exactly all about. Now, let me give you a little bit of idea what an injector is. An injector obviously is the component that injects the fuel into the combustion chamber. Now the pressure at which that fuel gets combusted into the combustion chamber is in the region of about 17,500 psi up to 25,000 psi. What does that mean? Let me give you an analogy. If you take two fully loaded of these F-250 trucks, two of them fully loaded, and you try to balance then those two on a, say, a 1.5 inch rod, that's about the pressure that it equates to. In other words, if I should increase that pressure to 40,000 psi, I would be able to cut steel with water. So that is quite substantial. The fact of the matter is that if the process does not operate perfectly, then obviously you will have incomplete combustion. Now that's two of the issues. Furthermore, if you look at the combustion chamber as such, you need to understand there need to be a certain amount of heat and a certain amount of pressure. But the biggest problems that the pundits are currently sitting with is that how can they control not only the unburned fuel portion of it, but how can they control the biggest culprit, and that's the nitrogen oxides. Because air gets burned to form oxygen and nitrogen oxides, or nitrogen then, for all it matters. And if your temperature is out of balance, then obviously you will create or generate much more nitrogen oxides. So they do have a problem, and that is the main reason why they also have a catalyst in the system, in an attempt to eliminate all those noxious gases. But you see, when it comes to unburned fuel, there is basically nothing that they can do to eliminate the unburned fuel that gets emitted through the tailpipes. Now let me just pause there for a moment. We all talk about nanotechnology. If you really want to understand and comprehend nanotechnology, then you should look at the unburned fuel portion. In other words, the emissions emitted through or by combustion or diesel combustion that is in the form of nanotechnology. And what is nanotechnology? That's the smallest of the smallest. If you take, for example, a sugar crystal and you reduce that sugar crystal 100,000 times, you'll get to an idea what nanoparticles means. Therefore, the unburned fuel portion that is currently suspended in the air comes in the form of nanoparticles. So nature actually teaches us exactly what nanoparticles is. So what do the people do? They're trying to block their nose and their mouth by means of a cloth or a handkerchief or whatever you want to call it, in an attempt to eliminate the inhalation of these unburned fuel, these particles. But they just fool themselves, because these things are suspended in the air and they penetrate right through the skin. Why haven't they addressed the unburned fuel portion? It's not easy to address. Let's address those things that we can make money out. Because if we address, and it is true, if we address the nitrogen oxides, we obviously will contribute to a higher amount of sales when it comes to the precious metals in catalysts. And even there, they haven't been able to achieve their objectives 100%, for the simple reason, and you can quote me. You see, when it comes to big organizations, to them, the most important part is profitability and not viability. So they will kill when it comes to profits. And let me explain this to you immediately for you to understand what I'm trying to say. If they now have taken out the sulfur out of diesel fuels, they've taken lead out of petrol, because, and it's truly so, that the sulfur in sulfur fuels results in sulfuric acid. And it also contaminates the catalysts in the catalytic converters. But that's not the biggest problem. If that was the biggest problem, they should have addressed actually the industry with the highest consumption of diesel fuel, and that's the marine application. The marine are still using diesel with a sulfur content of 3%. And that is the biggest culprit and the biggest contributor of not participating in a clean environment. Now, if that was of a big concern, am I right in asserting that they should have actually then addressed that issue at first and left the sulfur out for a while? However, if you really want to know the truth, the biggest problem in contaminating the environment is a product that you get in oils by the name of zinc didrophosphates. And why haven't they addressed that? For the simple reason, there's not a substitute for zinc didrophosphates. Of course, there is a legion of other products that can be used, but not at such a fantastic price. You see, price is the important part. So they've neglected that, and they got the people to focus on that is not so important. Now, I know that the purists of those that might listen to this DVD will obviously have a profusion of inconsistencies regarding the simplification of this whole strategy or contention which I'm proposing to you. Fact of the matter, this is the truth. So the fact is, what do we do to really address the issue? Let me start in saying that whatever comes from the big majors, one needs to understand it is so that it will adhere and comply to the latest fuel specification. There's no alternative to it, as they make no room for any aberration in their production lines. Then my question is, why is it so that some of the great respected institutions had to do a research and had to do a research on the quality of fuels and discovered that some of these bulk deliveries from the refineries on diesel fuel contains up to 25% petrol. Some of the fuels contains a high amount of kerosene due to the fact that there is always room for big mistakes. And therefore, we as the general public just perceive that whatever comes through the majors are in top quality, and that is not true. The fuel needs to burn within the first quarter of the stroke. And that first quarter of a stroke will take 1 millisecond. Now, how long is a millisecond? Let me try and explain to you the length of a millisecond. If you drive with your vehicle at, say, 96 kilometers per hour, then it will take the time that you will cover, say, 7 centimeters. That is the time of a millisecond. So now I can say to you, totally impossible. They can do whatever they do, so there is always inefficient combustion that will take place. And why is there inefficient combustion that take place? Purely due to the fact that the fuel does not burn properly. And why doesn't the fuel burn properly? Due to the complexity of fuels, be it diesel fuel or petrol fuel. If you look at diesel fuel or petrol fuel, you need to understand one thing, that it consists out of more than 1,000 different components, and which contains more than 220 different hydrocarbons. So it's a very complex substance. And the biggest problem with the complexity of fuels is that it has a high surface tension. And due to the high surface tension, it does not combust properly. So in layman language, what will happen is you will find that you will only have combustion in a first phase. And in your second phase, the little flame will die in the vine, so there will be no combustion that will take place, which results in unburned fuel. Now, what happened with this unburned fuel? Only two things can happen with the unburned fuel. It escapes via the tailpipes in the air and participate lovely to a bad environment in the form of nanotechnology, or in the form of nanoparticles then. The other part is obviously, the other part escapes via the rings, gets into the oil, and the oil people will then say to you, this oil forms sludge, and it forms carbon, and it forms varnish. And that is because of the morphological reaction of the components in the oil. That is so far from the truth that I do not have actually the words to explain that to you. Oil can never form sludge. It's due to the unburned fuel that gets entrapped in the fuel, or in the oil, that forms the sludge. Now, what is sludge? Nothing more than mud. That's what sludge is, in layman language. What you have is you have a lot of varnish. Now, what is varnish? If I take this table, and it's a wooden table, and I put normal varnish that I buy from a hardware store, I put a layer of paint onto it. By putting a layer of paint onto it, what do? I interfere with the tolerances of the components. There's a direct influence on the specification of the so-liked original equipment manufacturers. There's a high amount of carbon that gets built up in there. Obviously, that impairs the lubrication abilities of the oil. due to all the contaminants. And we'll get to the water part now as well, because as you combust, two things get formed, carbon dioxide and water. So water goes also and it gets into the fuel. So let me immediately say to you, the most important calorific value of fuels is the total base number of fuels. The moment the total base number of fuel starts dropping down to a certain level, you have to replace your oil. Otherwise you will have detrimental side effects and quite an impairment on the quality of the fuels. So needless to say, if the fuel or the oil loses its lubrication abilities, then you have an excessive amount of wear that's taking place. Now there's two types of phenomena of wear that takes place in oil, which is called the hydrodynamic lubrication, which normally occurs onto the journals, and then the dangerous one, which is the boundary lubrication. Exactly what it says, is right on the boundary. So boundary lubrication, once that component breaks through the film strength of the oil, you have welding that's taking place, excessive wear that's taking place, a very low coefficient of friction that's taking place. So needless to say that this will result in a high amount of metal particles that will get suspended in your oil. And that obviously will work against the lubrication abilities of your oil, will obviously result in excessive wear and a high maintenance costs that's taking place. But also would it work against the fuel consumption, because the better your components operates, the lower the friction, the lower the anti-wear possibilities in the oil, the better the engine can operate, and therefore you have a smooth run. And by just addressing that, you should have a substantial fuel saving. So that's the biggest problem that's happening due to the fact that you have incomplete combustion. What's even more, wherever you have water, and water is always prevalent in such an application, where you ever have water, you have a certain amount of microorganisms, bacteria, which happens to be the most sophisticated organism or bacteria or little life parts, if I may say it so, call it that way, which is extremely clever. What it does, it lives in the water and feeds on the oil or on the fuel. And what it basically do, it coagulates and breaks off and coagulates. And then the people, especially when it comes to the fuel side, will say to you that this fuel has a lot of algae build up in the fuel. It can never build up algae. It's because of the coagulation, because of the film strength that these little microorganisms sort of create. And what can you do to eliminate that? Nothing. There's nothing in this world that can break down the film strength or break down the biofilm of bacteria. The only product that can be used successfully is a product called chlorine dioxide, which is a gas, not permissible, not even anymore in municipal applications. And what have we done? The only way in really eliminating that, let me give you a little bit of a secret, is if you can put some hydrogen peroxide into your fuels, you might be able to eliminate it to a certain extent. In collaboration with one of the top companies in the world, we've developed a product that's based on hydrogen peroxide to be used in certain applications. And this is exactly what our product contains also. So that eliminates all those fatal, so to say, contaminants that gets built up in your oil and in your fuels. Suffice it to say, at this stage, I'm about to believe that you understand that this is not something to be considered. It becomes a necessity. So how does our product work? Let me tell you that the composition of our product is exactly the same composition of that of fuels, because our product is a fuel. So we're not making use of anything that's totally irrelevant when it comes to the chemistry of fuels. Therefore, you will find that a lot of people will address you and say to you, but they've tried to do an analysis on our product, a spectral analysis on the product, and they find certain substances in there which is exactly the same as that you should find in fuels. So what is it all about our product? And that is exactly the uniqueness and the secret of our product. What have we done? We've just changed the methyl ions a little bit around, and we have achieved our objective in breaking the surface tension of the fuels without having to interfere with the calorific values of the oil, of the fuels. Therefore, our product complies to the SUNS 342 spec as well as the one SUNS for the petrol spec. In other words, if you use our product in fuel, you're blending fuel with fuel. It's like having this glass of water. I will sip that glass to half the size, and you bring me a bottle of other water, bottled water, and we put that, we can fill it up with that other bottled water. Then I would challenge the most sophisticated analytical company in the world to tell me what part was water was out of the jug and what other part was out of the bottle. It's totally impossible. How can you ascertain the difference between a hydrocarbon and a hydrocarbon? So what is the primary purpose then of our product? The primary purpose of our product is basically just to bring